You suck as a software engineer if you're uploading 10 gigabyte files through your backend. Sounds harsh, but this mistake shows up in system design interviews all the time. All right, here's the situation. You're building a video platform where users upload huge videos. The first solution most engineers think of is simple. User uploads the file to the backend, and the backend uploads it to S3. Done, right? Now watch what happens. A user uploads a 10 gigabyte video. Your backend first downloads all 10 gigabytes from the user. Then it uploads the same 10 gigabytes to S3.
Your server just handled 20 gigabytes of network traffic for a single upload. And here's the interesting part. Your backend didn't actually need the file. The final destination was always S3. So why is your backend acting like a middleman? The simplest production architecture is surprisingly different. The user first asks your backend for permission to upload. That's it. Your backend checks things like file size, file type, whether the user's authenticated, and where the file should be stored. Then, instead of accepting the file, it generates a temporary upload permission called a pre-signed URL. Think of it like a one-time VIP pass. It might say, for the next 15 minutes, you're allowed to upload exactly one file to this exact location in S3. Now, the user uploads the 10 gigabyte file directly to S3. The backend never touches a single byte of that video. This works until someone asks, what's stopping anyone from uploading random files into my bucket? This is where things get clever. That pre-signed URL isn't just a normal link, it's cryptographically signed by AWS. When S3 receives the upload, it verifies the signature, checks whether the URL is expired, confirms the upload operation is allowed, and validates the object path. If everything matches, the upload succeeds. Otherwise, 403, forbidden. That's why companies like YouTube, Instagram, Dropbox, and Netflix don't stream massive uploads through their application servers. Their backend handles authorization, not transport. The result is lower bandwidth costs, fewer backend bottlenecks, faster uploads, and an architecture that can scale to millions of users without your servers becoming expensive traffic relays.